All right, I'm going to be going over conditional probability, which is one of the harder topics on the test that you guys have tomorrow. So I'm going to be starting with the Venn diagram handout that you guys got in class, the one about the three wines. That way you guys can follow along for these first examples. So they started out by giving us three circles. Wine A, wine B, and wine C. So whenever we have, and they also gave us like a list of number of people that liked all the wines. So whenever you have a question like this and you need to draw your own Venn diagram, always start in the middle and work your way out. So if we only had two circles right here, we would start with this middle part and work our way out to the outside. Since we have three, we need to start in the very middle, this part right here that has all three circles overlapping, and work our way out. So in our information, it told us that 80 people liked all three wines. So that means that 80 people need to go in this all three wine section right here because all three circles are overlapping. Now we need to work our way out. So we need to go to this one, and this one. So we'll start with wines A and B. They told us that 83 people liked both wine A and B. Well, you would think that you'd put 83 people right here, but this 83 people already includes these 80 people right here because these 80 people liked wine A and B. They just also happen to like wine C. So in order to not count them twice, we need to subtract the 80 people that we already counted right here to give us the 3 people that only like wine A and B. So again, these 3 people only like wine A and B. These 80 people like wine A, B, and C, which gives us our 83 total people that like both wine A and B. All right, moving on to A and C, they told us that 81 people liked wine A and C. Well, again, these 80 people also like wine A and C. They just also happen to like B. So in order to not count them twice, we need to subtract these guys out to give us 1. That's an underline. So now we have this one person alone that likes wine A and C. Moving on to B and C, they told us that 85 people liked both wine B and C. But again, these 80 people also like B and C. They just also happen to like A. So we need to subtract them out to not count them twice. And we get 5 people in this category alone. All right. Now moving on to this last part, these last 3 circles. They told us that 86 total people liked wine A. Well, this person liked wine A. These 80 people liked wine A and B and C. And these 3 people also liked wine A and wine B. So in this full circle right here, we should have 86 people. Well, we already have these 80 people right here. We have this one person right here. And we have these 3 people right here that we need to not count twice, right? Because this 86 people includes all of these people plus however many people only liked wine A. So that ends up giving us 2 people. 86 minus 80 minus 3 minus 1 gives us 2. So now 2 people like wine A only. All right, wine B. They told us that 89 total people liked wine B. So in this whole circle right here for wine B, we should have a total of 89. We have 80 right here. We have 3 right there in this part, and 5 right here. When we subtract these 88 people that we have right here, we end up having one person. Only one person only likes wine B. All right, for wine C, we have, what does it say? 90 people liked wine C. All right, so if 90 people liked wine C, we need to have 90 people in this whole circle right here. But we can't count these guys twice. So we're going to subtract 80, subtract 1, subtract 5, and we end up getting 4 people that only like wine C. All right, now that we have the people that only like wine A, only like wine A and B, only like wine B, so on and so forth, we need to add them up to see how many people that we have. All of these numbers added together, 2, 3, 1, 85, and 4, gives us 96 people. Well, we were told that 100 people are surveyed, so we're missing 4 people. These 4 people go right here in our larger box because they didn't like any of the wines. So they're still counted in our total, but they don't count towards any of the wines. All right. Next, it follows up with some questions. The probability that they like none of the 3 wines. Like no wine. All right. So for probability, we're going to be doing the number of desired outcomes divided by the number of total outcomes. So for our problem right here, there are 4 people that don't like any of the wines. So that's going to be our number of desired outcomes. So our answer is going to be 4 divided by our number of total people, which is 100. And you guys can simplify that, so I'm not going to. All right, part B. Probability that a person picked randomly likes wine A and not B. So they don't like wine B, but they like wine A. All right. For this one, these are all the people that like wine A. So we need the people that like wine A, but they don't like wine B. So anywhere there's overlap between this circle and this circle, we cannot count them because they also like wine B. So for this person right here, he likes wine A, but he doesn't like wine B. These 3 people right here, they like wine A, but they also like wine B, so we can't count them. 80 people here, same story, they like wine A, but they also like B and C, so we can't count them because they like B. This one person right here, he likes wine A, but he doesn't like wine B, so we're going to count this one person. So we have these 2 people right here, plus this one person right here, divided by our total number of people is still 100. So we get our answer is 3 over 100. All right, letter C. The probability that they like any wine except C. All right, so they can like any wine they want to, but they can't like wine C. So basically, we're going to take this circle for C. This goes all the way around here, and we're just going to ignore it. So any people that fall inside this circle, we can't count. Sorry, my phone fell asleep, and I don't have the worksheet. All right. So if they fall within this circle, we can't count them because they like wine C, and we want people that don't like wine C. So that leaves us with these 2 people right here, these 3 people right here, and this one person right here. That gives us 6 divided by our 100 total people. We still have 100 people because we're still picking randomly from the whole people, from everyone. Sorry. All right, letter D. The probability that they like exactly 2 out of the 3 wines. All right, so for this one, they can only like 2 of the wines. So we'll just go through all the numbers right here. These people, they like only 1 wine, so they don't count. Same thing for this one guy right here. He likes only 1 wine. He or she likes only 1 wine. This person right here, these 4 people right here, they like only 1 wine, so we can't count them. These 80 people right here, they like all 3 wines, so we can't count them either because they like more than 2 wines. And then this person right here, this one person right here likes wine A and B. They count because they only like those 2 wines. Right here, they fall within these 2 circles, right? And not this third one, so they count because they only like wine A and B. And these 5 people right here like only wine B and C. They only like 2 wines. That gives us our total 9 out of still 100 total people, which the problem told us in the beginning. All right. Now for the important one, the one about conditional probability. All of these are kind of warm-up questions for this last one. The probability that they like... Given that a person likes wine A, find the probability that they like wine C. All right. So for this question, they introduced you to like a new concept, the word given. You guys have obviously seen the word given before, but this is again a refresher. So I'm gonna rewrite this as the probability that they like wine C, given this vertical line right here stands for the word given, that they like wine A. All right. So whenever we have this given sign right here, or the word given, we know we're working with conditional probability. And what conditional probability is, conditional probability, what that is whenever we have this line right here that stands for given. So the probability of A given B is equal to the probability of A and, this arch thing stands for and, probability of A and B divided by the probability of B. So our given, the probability of our given event, right? The given wine A, they like wine A, is always going to be our denominator. And the probability of A and B happening is going to be our numerator. Let's work through the wording of the problem. Given that a person likes wine A, that's this given part right here. Given that they like wine A, that means that no matter what, we are picking someone that likes wine A. So any person outside of this wine A circle is just ignored. That leaves us with everyone that likes wine A. That's our denominator. Again, like wine A is our event B, so our probability of B is going to be our denominator. So all the people in this circle, 80, 1, 3, and 2. That comes out to 86. So our denominator is 86. Again, given they like wine B, no matter what like wine A, no matter what, we're picking someone that likes wine A, right? So we can ignore everyone that doesn't like wine A. That's our denominator. The probability that they like A and B. So they like wine A and C. So if they like wine A and C, that's going to be these 80 people plus this one person right here, right? Because they like both wine A and C. These people like A, B, and C, which means that they like A and C. And also this one person right here, which likes only A and C. This gives us our 81 people in the numerator, and that's going to be our answer. All right, so that's how it is with a Venn diagram. We can also do this with a frequency table. For a frequency table, they'll usually give you a chart like this. They'll rarely ask you to make a frequency table. Or at least you haven't had to yet, I don't think. You might have to fill one in. But for the most part, they're going to give you the skeleton of what it is. So I'm going off the same piece of paper, it's just the second half. With the first problem of this one, they have the probability, or I'll just ask the question. To the nearest percent, what is the probability that a student who failed the exam got less than 6 hours of sleep? All right, that who failed the exam part is your given. So there's a few ways that they're going to denote your given. They're either going to say the word given, like we did in the last problem, like given that they liked wine C. Do they like wine A or B? Something like that. Or they'll use a word like who. So in this example, they use the word who. The probability that a student who failed the exam should like send an alarm in your head. All right, that's my given. So I'll write that. The probability of a student who failed the exam, I'll write it out here, who failed the exam, the probability that they got less than 6 hours of sleep. Less than 6 hours of sleep. And this is the less than symbol, greater than symbol. All right, so given that they failed the exam, remember we have the probability of less than 6 hours of sleep and failed the exam divided by the probability that they failed the exam. All right, these are our numbers. This is how we need to figure this out. So I always start with the denominator. Who failed the exam? All right, the number of people who failed the exam is all of these people right here. These 10 people and these 8 people all failed the exam. So that's going to be our denominator. These 18 people failed the exam. Probability that they failed the exam, we're out of these 18 people. No matter what, we're picking someone that failed the exam. So our denominator has to be these 18 people that failed the exam. Now we need to find the people who got, here, I'll box this column in, because no matter what, we're picking someone that failed the exam. So the probability that they got less than 6 hours of sleep. So over here, we now need the number of people that got less than 6 hours of sleep. Well, we're picking someone that failed the exam, no matter what, that failed the exam. This is the only box we care about, this one right here, where they got less than 6 hours of sleep and failed the exam. These 12 people that passed, they don't matter because we need someone that failed the exam. So our numerator is going to be these 10 people that failed the exam and got less than 6 hours of sleep. Less than 6 hours of sleep and failed the exam. And this is our answer. All right, next question. The probability that they failed, let me read it. What is the probability that a student who got less than 6 hours of sleep failed the exam? So the probability that they failed the exam, and again, here's our given statement that doesn't have the word given in it. Who got less than 6 hours of sleep? Less than 6 hours of sleep. All right. So no matter what, they had to have gotten less than 6 hours of sleep, right? Because that's our given. So if we're going to write it like we did right here, people that failed the exam and got less than 6 hours of sleep divided by this second one right here, the given probability of less than 6 hours of sleep. All right, so here we have the people that got less than 6 hours of sleep. So that's going to be all of these people, because no matter what, we're picking someone that got less than 6 hours of sleep. There's 22 people who got less than 6 hours of sleep. That's going to be our denominator. All right, the probability that they failed the exam and got less than 6 hours of sleep. So again, we're dealing with this less than 6 hours of sleep, and they failed the exam. So here we have this intersection. Bam. That cell right there, 10. All right, so some of you may be asking, how come right here it says the probability that we have less than 6 hours of sleep and failed the exam divided by the probability that we failed the exam? How come we're using the number of people that did both and the number of people that failed the exam? Like, for example, right here, probability that they failed the exam. We have the number of people that failed the exam. It's not quite the same as the probability. And I'll actually rework this one using the probabilities, and we're going to see something interesting happen. So, let me move this up a little bit. All right. The probability less than 6 hours of sleep given they failed the exam. All right. So, we're going to set up the problem like we have been in the past. When we have something like, when we have a given or a conditional probability question, less than 6 hours of sleep and failed the exam divided by the probability that a person failed the exam. All right. So this formula demands probability, but we've always just been using the number. So we're going to use probability for this like one kind of in-depth example. So the probability that they got less than 6 hours of sleep and failed the exam. So that's going to be these 10 people right here. We have 10 people that got less than 6 hours of sleep and failed the exam. And the probability of drawing this one person is 10 out of 120 total, right? So we have 10 out of 120 for our numerator, because it's the chance, or the probability, that we pick these 10 people out of the 120 total. And we're going to divide that by the probability of people that failed the exam. Well, the people that failed the exam, we have 18 people that failed the exam. 18 out of the 120 total. 120 total. So here we have a fraction divided by a fraction. So we can actually write this as multiplying this numerator by the reciprocal of the denominator. So it's 10 out of 120 times 120 over 18. These 120s cancel out, and we get our final answer of 10 divided by 18, which is the same as this number here. So you can see that when we actually use the probabilities, we get the same answer. So we just take the shortcut and take these 10 people and divide by the total number of people that failed this exam.